kind of see both of them. Jesus Christ. It's a little experiment. I'm not sure if it's going to do much for us, but basically what I'd like to do for the people in the classroom here, you guys at home won't see this, but I want to have a projection of the program on the wall while I'm discussing it online. If you're home, the thing is you have the programs available to you. You can swap back and forth on your own. We're in class here, we're kind of limited to doing whatever I'm doing in front. So don't, this doesn't affect you, but it'll affect the people in the classroom here. To begin with, and today I want to cover a couple of things. I want to cover some things about strings that we haven't touched on before. Strings are just text, that's all they are, is text. And a string is you can have a string as a variable or as a literal. Now these are things we've already done before, but I'm going to do them again just because I want to connect new stuff to them. You can have a string variable that looks like this. You can say variable, and you can say apple. And if you said equals 0, it creates a number automatically. So if I said this, equals 0, when I define anything, it's going to create a number for me. But if I don't want it to create a number, I want it to maintain its neutrality so that it doesn't know what it is. I just say create this variable called apple, like so. And now you have a variable that you can either make a string or a number, depending on what you want to do. Okay, that's a variable that can be a string if you want it to be a string. So for example, if I said down below in the program, I said apple equals, quote, hello, then the words hello would go into apple and it would become a string variable. That's how it would just happen. The other way of talking about strings is talking about them this way right here. And these are normally called data literals. Whatever's inside the quotes is the information in the string. This is the variable right here that holds the information, but that's the actual information. So when you put quotes around something, it means that the words themselves that you see are actually the contents of that string. That's what's inside that string. We've done this before too. We've said apple, and I said equals hello. Plus, quote, space mark, Sam. Like so. And what that does is it takes this string literal right here, and it adds it to this string literal right here by just gluing them together. That plus sign is just sort of a glue that holds the two together. Notice in here I put the quote, then I put a space right here. The reason why is because you want the thing to say hello, Sam, like that. So you have to create that space artificially. It doesn't work if it's in here. It's got to be inside these quote marks. So that's why I put it here. I could have put it after the O if I wanted to. I put it before the Sam. So in other words, that's how you, when you glue them together, if you want to get a space in there, that's how you can do it. But that's how you glue two literals together. So that's actually what you have when you have a variable, string variable. The other thing about string variable that's interesting that we haven't talked about is that strings, like apple for example, strings are actually, in the mind of the computer, they're thought of as individual characters. And this is character 1 right here, character 0. This is character 1, 2, 3, 4. So if you look at that, the computer knows that the first character is 0, seconds 1, 2, 3, and 4. And it knows that it has a length. The length of the string is 1, 2, 3, 4, 5 characters. That's actually how long the string is, okay? Well, it turns out that we have if I have a variable called apple, and I want to know how long it is, we can do that. Up to this point, this is what we've been doing. We have a variable called apple, okay? And we say, what is its value? Like so. That means what's in the variable. It means like A-P-P-L-E. No, it's a variable called apple. Let's say it contains core, like that. So in this variable right here, the word core is actually in it. Apple's the name of the variable, but the actual contents of that variable is core. When we say apple value, that's what you get. You get the core of the thing. You don't get the length of it, okay? But it is possible to get the length of it by saying len is equal to, use any variable you want here, any variable you want, and they use a very simple strategy. They say apple dot length. That's it. That's how it's done. So instead of saying apple dot value, you can say apple dot length. And if you say apple dot length, what comes over to here is 1, 2, 3, 4, 5. Is the number 5. So it tells you how long the thing is. And that's what that does. Okay. On the screen, I have a bunch of other ones that I want to talk about. The first one is number. We've done that one before. We just take the if you have a string that contains a number, and you want that number, what you do is you say number and put the string that you have in there, and then your number will come out the other side. Out where your number is, you'll have a number. Now, if you don't get a number, suppose you had the word hello in the variable, the string. If you had the word hello in there, it wasn't a number at all. What you get is this. That's what, when you go to look at it, that's what you're going to see, is not a number. That's what it means. So in other words, if you try to convert a number, a string to a number that is not a number intrinsically, there's no number in it, it's like got some characters in there, other than numerical characters, it'll give you an error, okay? And that's what the error is. That means it's not a number. It won't show up. The real problem is if you make that mistake in your program, and you try to add that to something else, it's not going to add. It's not going to like it. What it's going to do is it's going to take, when you try to do the plus sign, it's going to take whatever you added to the NaN, it's going to see the NaN, and it's going to make it into a string. It's going to say NaN in some number. It's just going to combine two things as strings because it doesn't know that one of them is supposed to be a number. So therefore, you've got to be sure that the thing in B string is, in fact, a number. Your program has to be sure that what comes in there is going to be a number, because if it's a string, it's going to blow your program. The second thing there, combining the two, I just did that over here someplace. If I have it left, I erased it. But basically, you're adding two strings together, IN, A string literal. In that case, I put the space before the A string literal, before the letter A there, between the quote mark and the letter A. That's where the space has to go, because it's the space you're gluing. The spaces around the plus sign don't mean anything. You can put that as Y, it doesn't care what you do there. So that doesn't affect anything. The third one there, to combine two strings, variables with a space between them. Supposing you had, like A string had something in it, and B string had something in it, but you don't want to glue them together like it was Joe Dart. You wouldn't want to glue it together as one thing. So what you do is you glue a space, plus a space, and then plus the last string variable. So in other words, if Joe was in A string and Dart was in B string, you'd have Joe space Dart. That's how that would look. You just simply add the space in there, the literal space. Number 4, to find out how many characters in the string, the thing we just did here is you take the string and put dot length after it, and that'll give you a number. It'll tell you how long the string is. I'm going to go up a little bit here for the next one. To change the characters in a string to lowercase, that's something we haven't done. It's actually easy to do. If you can read that up there, it says whatever the string is that you have, my word is the string, and then you put dot to lowercase. Be sure to put those parentheses there, because it's that right there is a function that's connected to the my word let me see if I explain this. We've actually avoided object, what they call object programming, because when you do object programming, there's a lot of things that you have to learn besides what we've covered. So basically I've avoided it, but what happens is, if you save a variable in a certain way, there are a lot of dot things that come with it that you don't even have to define. They're built into it. They come with it automatically. And one of them is a function that's built in that says to lowercase. And what that does is, if you put your variable name dot to lowercase over here, that lowercase then will act on your variable. So what happens is, when you say to lowercase, anything that's in my word, supposing you had capital H, E-L-L-O, and you wanted to get rid of that capital H, if you said to lowercase, that capital H would drop to a regular character. So what comes out the left side there, my lowercase string, what comes out there is every capital letter is reduced to lowercase, and so what you end up with just lowercase characters. Now you might wonder why you want to do that, but if you're saying if something equals something else, and this one has uppercase and this one has lowercase, the same word with uppercase, they won't match, because they're going to match exactly. Something, you can't say this, you can't say that capital H, E-L-L-O, is equal to lowercase h-E-L-L-O, because they're not the same. If you have uppercase one, so by reducing everything to lowercase before you do your comparisons, your if statements, or whatever you're going to do, then you have them all in the same case, and you're not going to have that problem. By the way, I should mention, that problem has come up in home assignments over and over and over again. What will happen is someone will save a file and give it an uppercase character in the beginning, a capital, whatever, and then in the program they'll write it in lowercase. So the name of the program, the name of the picture in the program, and the actual name of the picture are not different, not the same. They're different. So what happens is you have to be consistent about that, because it's very concerned about up and lowercase. So that's one of the things you have to do. And the next thing is you got here's my glasses. You have if you type something in, so let's say it asks me for some information. Say, enter your name. Enter first name, for example. And what I did was, in the area right here, I put in my thing, and I put space, 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 Joe, space, space, and hit return. Hit enter, or whatever the enter button was. What would happen is there'd be a bunch of spaces in here, and the spaces that I hit, the space bar. And the problem is, if I went to say, if the thing I just entered, we'll call it data, equals Joe, do something. Do something. Well, what happens is, it wouldn't see it, because it would say, is data equal to Joe, and it's not. Data is actually space, space, Joe, something else. The characters in it that aren't supposed to be there. So what you can do is, you can use that function right there, right in the beginning. In other words, you bring everything to lowercase, it brings it all to the same case. And the second thing is you do this myword.trim. What trim does is it takes all the spaces from both sides of your thing and cleans it up so that you just get exactly what the words are, or numbers are, or anything. And so that's a very handy thing to use. We're going to use both of these today in class, by the way. The next two, 7 and 8, online I have a description of that, and I think yesterday's, the last class, the day before yesterday. So you should read that description of between substring and substr, and we did a little bit of it in class. And also there's a program that you can actually play with that will actually allow you to put in a phrase and find out what the substr is and the substring. You just type in your words and say, I want this character for this character, and see what you get, so that you can see how they really work. And that's pretty much, these are actually a lot of the string things we haven't done before, which I'm going to do in this next program I'm about to show you right now. Is there any questions about any of these? Does it all kind of make sense? Just the instructions. Okay, the program question. Go ahead.
Can we find this again? Is it one of the links on the website?
It's on. Yeah, it's in
okay.
today's. It's in today's.
Oh, lecture.
Yeah, it's listed in today's. Yeah.
Okay.
Okay, so next question. Let's look at the program that actually uses these things. See what it looks like. The program's called. Actually, let me know what it's called. It's available here. Right here. It's a Pig Latin program. below. See, apple. An apple. Banana. See, it actually converts what I'm saying into Pig Latin. And Pig Latin, whoa, that's not good, is it? Too high up there. I was wondering, you guys are looking kind of mystified. Okay, get it down. Get that a little bit. Let's see if I can get that. Okay, how's that? Oh, you gotta get it really down. Can you see it now? Yeah, okay. Okay, I'm going to restart it because once it runs like Fluxy, it doesn't understand what I'm saying anymore. Apple. Notice that it understood the word apple with a capital F, but it still did the translation. It did it because I told everything to go lowercase. I'm going to show you the program in a second. Banana. And there it took the consonant B and put it at the end, and then added the AY to it. So there's two things it does. If it's a vowel, it simply adds a Y. If it's a consonant, it puts a consonant at the end and then adds a Y. It's a kind of simple program, but what it does is, amazingly, it uses almost all the instructions I just listed there. Not all of them, but a lot of them. So you can get to see how all the string instructions work with this one program. I also threw in where you say it. I could have written this so you typed in the word and it would do it, but I just made it. Listen to me. Let's take a look at it. Here. It's right there. So the way the program works is I'm just going to write the function that actually does the conversion. I'm not going to write the. I'm not going to talk about the instructions on their own, or how they're actually. This program here tells you how everything's put together. I'm just interested in adding these new instructions and seeing what they do, what they actually do for us. Well, to begin with, it's a verbal thing where you talk to it, and it picks up whatever you said, converts it into a string, and then that string comes in as transcription, and that transcription we send it to Word, and then we send the word out on the screen so you can see what you actually said. Now here comes the part where you do the actual conversion to Pig Latin. To begin with, let me just write the rule quickly. If I had the word apple, and I said convert that to Pig Latin, it would look at this and say, that's a vowel. So therefore, the only thing that it would do to make this into Pig Latin is it would add AY to the end of it. So when people say it, they say apple A instead of apple A. If it's banana, because it begins with a consonant, that's a different situation. In the case of banana, what it has to do is take this B and glue it onto the end of this. And then they add AY to it. So it's a banana base. So in other words, apple A and banana base, they're different because they have consonant, a vowel to consonant. Okay? So what I have to do in my program, I have to look at the first letter. That's how the translation works. You look at the first letter, you say, if it's a vowel, do this. If it's a consonant, do that. Turns out there's only 6 vowels, so we can get the vowels out of the way quickly. H and those guys are treated like consonants. So the first thing you want to do is, once the program starts, it puts the information that you have into my word. So my word contains the information that the person said. Now what I want to do is I want to be sure that it doesn't have any spaces on either side of it. So the first thing I do is I write my word equals my word, same variable, dot trim this thing. And that right there will take all the spaces away. So all the spaces are now gone from both sides. So if the program might do that even. The listener program might put some spaces in it. You don't know. It depends on what it said before and what I remembered. So you got to be careful. You want to be sure there's no spaces in the thing that you're going to look for. So you lock it down so it's just the stuff that you're looking for. So first of all, you trim it and get rid of the spaces. And then what it does, it takes the very same thing and it says, now bring it to lowercase. So it says my word now is equal to my word, and it's capital, my word, two lowercase, only the C is capitalized, two lower case. This is the only thing that's capitalized there.
L is capitalized.
Lower is capitalized? Yes, you're right, you're correct. Lowercase, L, okay, for lowercase, so just those two, L, this one here and this one here, that's all it's doing, we see that function itself. So that'll bring the things to lowercase, all the characters will be brought to lowercase, so now you have no spaces around them, and it's all in lowercase. So you get something to work with, and finally what I do is, I want to take the first character from that word, from my word, and I want to put it in a place I call first. Because I want to see if that character what is that character? Is it a consonant or a vowel? So I pluck it off and put it in the substring, I put it away. It doesn't affect my word. My word is still the same as it was before. But I'm taking this one character and I'm taking it away and putting it first. So I did that with a substring. Now, what the substring does is, it says, starting at position 0, take one character. That's what I'm saying. I'm not saying go from position 0 to position 9. I'm saying start at position 0 and take one character. So it just takes the 0th character, the first character in the string. That's all it takes. So the variable first is equal to my word dot substring 0, 1. Right. Watch my writing, by the way. I'm sure I've done everything here. Okay, so there's what you're taking it out of, and then you're going to start at position 0, take one character, you're going to put it in here. So this thing right here, whatever the word that came in, it's going to have one. Let me put apple over here, and banana over here. Those are two examples of the possibilities. One gives you apple. So he said apple, some said banana. Okay, so now, if it was apple, in this case right here, A would be in first. If it was banana, B would be in first. So now you'd have captured that first thing. Then what I want to do is, since there's only 1, 2, 3, 4, 5, A, E, I, O, U, there's only these 5 vowels, what you do is you say, if it's any of these 5, operate it like it was apple. If it's not any of these 5, you have an else there, and the else says operate on it like it's a consonant. Okay, so in other words, you're either going to get it operated on right off the bat, just like it's a vowel by adding AY to it, or you're going to go to this other routine, which is going to pluck off the first character, put it in the back, and then add AY to it. But the first routine is very simple. It says if the first character is equal to A, or the first character is equal to B, or the first character is equal to I, or the first is equal to O, or the first character equal to U. Any of those. These are all ors. This is like the barn, okay? If any of the doors are open, you've got to go in the barn. You can get to go in. So therefore, if any of these things is true, because it's oring them, even if this one's true, it'll do it, which it'll do it constantly. If this one or that, no matter which one's true, if any of them are true, if none of them are true, it won't do it. But if any of them are true, what you do is you say, okay, just take the first, you say, you call it the answer, what do they call it? Out to, I send it right out. Okay, so I said out to dot value. I sent it right out to the front screen is equal to the first plus AY. So I just added the AY to the first, and that's it. And that's the end of this part of the routine. So in other words, if it's a vowel, you're out. Home free. It's easy to do. It's a little bit difficult, a little more difficult. You get 3 segments in the next one. Well, first thing is, here's what happens. You got this word banana right here. Okay. And this right here is character 1. Okay, it's the first character in the thing. But what you want is, you want to take this piece right here and take it away and put it someplace. And you've already got this piece taken away. So basically what you want to do is you want to glue them back together in reverse. You took them apart like that, and now you want to glue this to the back end because it's going to be an animate. So what you do is you say, okay, the length of this thing is 1, 2, 3, 4, 5, 6. Okay? And here's what I did. I said, else down here. I'm going to write it right here. I'll write it in here. This is the else part over here. What I did was I started out by saying the length. First of all, you have to get the length of the thing. You say else, yeah, variable length. Oh, yeah. Like so. So now I have the length of the thing. And then I say, you get a variable, I called it the tail, which is the last part of the thing. This is where it gets interesting. I call it tail. And what I did was I said, take my word, the original expression, banana, right here, my word. And this time, substring the thing. Now here's where it's interesting. Substring, what that does is starts at this character, and takes, let me see if it's right. Yeah, substring starts at this character and goes to the length character, goes to the last character, whatever it is. Okay, and the interesting thing is, it takes the first character and it takes that many characters and it locks it in. And what you do in this case right here, you get 1, comma, len. And the reason why length works, by the way, you'd say, well, that shouldn't work because the length of the thing is this thing over here. You don't want to start here and take that length. But it turns out because that particular instruction doesn't work that way, it takes 1 less than the character at the upper end. And what you have left is the first character plus the length, which is 1 less than that. You have the first character to the end. This is the first character. This is the 0th character right here. We took that out and put it away at B. And we take this thing over here and put it away at tail. So this one's called tail over here. And this one over here is called first. So that's what we do. We pull them both apart. And now what I do is I glue them back together the opposite way. I take tail and I glue the first to it. Then you glue AY to it. And that's it. That's how you do it. In other words, you take the first character away, take the second, you don't hurt the original. The original's still the same as it is. Take the first character away, take whatever's left over away, glue them back together like that, and add AY to it, and you got it. And so this program actually, when you look at it, it uses all of the string. It's a good example of using all the string functions. Okay, does that make sense to you? I think that line number, tail, my word, substring, 1, comma, length. You got to think about that a little bit because the character it takes is not the length character. It always takes 1 less because the substring doesn't work right? It always takes 1 less. So therefore, it's not going to take that many. It's going to take 1 less than the entire length, which is exactly what you want. You don't want it to take from 0. You want it to take from 1. So you want to cut 1 character off. And so it does the right thing. And that's pretty much it. That's how this program works. And at the outside end, all you're doing is you're simply talking to it. And you got an out to area, which sends back what you said, so that you can verify that you said this word originally. And then it has an out 1, which is probably where the Latin goes, the pig Latin goes. Okay? And that's how it starts. That's how it works. Let me just bring the program up so you can see the bottom here. See, nothing much going on there. That's the same stuff that we do all the time. I did do one thing at the beginning though. The recognizing program, I went to recognize the star right away. So this doesn't require any kind of, it requires the listener to hear you. But to do the pig Latin, it doesn't require anything special. That's just the program. the listener allows you to talk to it, that's the only thing it does. Okay, so other than that, you wouldn't have any problem. And down and unload, we had to go to recognize because that's what starts listening. You have to start it up. Remember that? That's how we, that makes sense? And so it starts listening to you automatically. You don't have to do anything. That's it. Okay, so that's those string instructions. I just want to show them to you. They're very handy for a lot of stuff. But if you get to writing things that have strings, because what you have to do with strings is you have to start asking questions. Like for example, I wrote a program for trigonometry. What it does is a person can say, give me the tangent of 30 degrees. Well, I had to look to find the word tangent to be sure they say sine or cosine. I had to find that. And then the thing is, tangent of 30 degrees, and I had to look to see if it was degrees or radians. I had to look for that expression. And then in the middle between those, I knew what I had was a number. So I had to cut the thing, chop the thing, so that I got rid of the tangent, I got rid of the degrees, and I got just the number. And then I did the calculation based on that number. So it became like a big, it's just like this program, except that you had to start cutting the thing up into several parts. That can happen if you're doing something more complicated. And don't forget, we also have a thing called index off, which will tell us where something is, if it's just available for us. I should add it to that list because that's a string function too. But that's the one that gives you a lot of information because it tells you where the character you're looking for is. Okay, so next question. Let's do the second program here. Let me go up one more right here. Okay, this is something we haven't done before, but the idea of it is to get from the computer, which the computer has, all of this information right here. The computer knows what time it is. The way it does it, by the way, is at some point in the past, I don't know when it was, but at some point in the past, it set the clock at 0. And then what it does is it keeps adding like microseconds to the clock. It keeps adding time to the clock to increase starting from there to telling us what time it is. And the thing is timed with like, some kind of a chip that's perfect. So what happens is that the computer's always got perfect time. And it tells you, it can tell you that time. And it has little routines to figure out what month it is, what day it is, and that sort of thing. And so to give you that access to that information, what you can do is you can use an include file called clock.js, which is, by the way, it's one of my programs. But what my program does, it simply does all of diddling to grab what we need from the clock. So if you add that, if you put that include clock there, and then from then on, once you do that, okay, you have these variables, JJ weekday, JJ month, JJ, and these describe what you have. This is the information that you have. And let me just run the next program and show you what it looks like when you actually use this stuff. This program, I threw one little thing in it just for fun, was to change this is just a button. All it is a button. It says, what time is it now? Just a button. But it also turns out that if you change the background color of a button, like I changed the background color to red, and then I changed the characters to yellow. You can do that in the style sheet. You can actually change the colors. So you can control what the button's colors look like, okay? Another thing I should tell you is it is possible to make a button that looks like a picture. You could actually have a photograph and hit that, click the photograph and it would work. I'll show you how to do that. Well, it's not a big deal, but it's one of those things you can actually look at how do you make a picture in a button. It'll show you the command. Okay, so basically here's what this one looks like. If I click on what time is it now, it gives me all the information about what time it is now. It comes right out of the computer, and if you hit it a minute from now, it will give you different times. It's one thing to write this down. It's another thing to try to figure out how it works, because it works in a very odd way. let me go over to the program here. Look at it. And put it up on the screen. If you look at the program, at the bottom, all you see is the input statements. And these input statements are just actually the output statements. You just simply want to show what the results are. So I have 8 of them here. I have 8. I ask what day is it, what month it is, what day of the month it is, what year, and so forth. I ask those questions. And then what I do is I show them on the front screen. That's all I do. Nothing going on here. But notice this. This is the important part. When you write this program, you have to include clock.js. So you have to have this. This has to be in any program that does this job. You have to have script. You have to have that to begin with. Okay? And then, if you look at the program here, when it goes to the time, see when I press the button, it goes up to the time to tell me what time it is. See that it says JJ time right there? That's the actual function that gets it for you. It goes out and grabs that time for you, the current time. So the first thing you're going to do in your function, when you're going to use this, what time is it, or whatever your function's called, here. The first thing you have to do is that right there, is the JJ time. And what that does is it goes up to here, says what time is it now, and it gathers all the information, what day, what time, what date, and all that stuff. Gathers it all. So now you have it in your machine. So now if you want to just show the time, suppose you wanted to show, well I did, I just showed, the first thing I did is I said, JJ weekday. So it tells you it's Monday, Tuesday, Wednesday, Thursday, it tells you what day it is. So I said out1 dot value equals JJ. Is it weekday? I used weekday. All lowercase, by the way. And so forth. Out2 equals JJ month. Out3 is JJ day. And when you run it, what you see is they just showed you, the program just shows you what the results are. Put it down here again. So if I press the button now, you see the minute and the seconds changed. Okay? Let me show you one more program here in this group. And this is one here. Now, this program introduces some interesting ideas. Yes. It's a clock. It's a clock where the hands go around. It's an old-fashioned kind of clock. And it's a second hand, an hour hand, and a minute hand. And the question is, you're starting with the information from the digital information from the computer. I went up and I said, you know, what hour is it of the day? How many seconds is it after that hour? After the minutes and so forth. I asked for that information, hours, seconds, and minutes. And then I said, how do I draw that now? How do I actually do a drawing of these things? Because I have to go from these numbers to the picture on the screen. And what that requires you to do is just to understand what actually goes on when you're looking for what time it is. What goes on is the clock has got 60 minutes on it, but a circle has 360 degrees. Not coincidental, by the way. It came from the same ideas. So basically, your clock looks like this. It's got 360 degrees in it, 12. You got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's essentially what it looks like. But here's what happens. Let me show you the program itself, and we'll talk about the instructions of it while we're doing it. Here it is again. of the program. What this does is it shows you the instructions that convert the numbers you get from the computer. See, what I did was I did it JJ time, and I found out what time is it now. And then I wanted to write down, I want to find out how many seconds. What's the second hand doing? That's the first thing I wanted to know. Okay? Well, if you look at the second hand, what it does is, each second, the hand moves 6 degrees. The hand moves 6 degrees. The second hand moves 6 degrees every second. And the reason why is because in 1 minute it has to go 360 degrees. Okay? So therefore, if you say it has to go 360 degrees, if you take these moves of 6 degrees and you multiply them by 60, you get 360. Okay? So in other words, what it does is it moves 6 degrees, so it essentially has 60 positions it gets into, each of them being 6 degrees between. And what happens is it goes to 360. So if you look at the program, what I wrote is degrees s, which is my variable, degrees s, is equal to the thing that it gave me, which was how many seconds it is, JJ seconds, times 6. And the reason why it's times 6 is because every single second that comes in, I have to multiply it by 6 to find out where it is, because it's 6 degrees for every second. So therefore, the thing goes, bing, 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 goes 5 times between each one of these guys. 5 times between here, 5 times between here, 5 times between here, 5. And you go around the entire thing, it goes 360 degrees. Okay? But I'm saying, I need the degrees because what I'm doing is, I'm doing a rotation, a simple rotation of this thing. And therefore, I have to know it's going to go 360 degrees. So I have to convert seconds to degrees in order to tell you where the thing is at any given time. And the way you do that is you say, well, each second gives you 6 degrees. So it's going to draw the thing at 12, then it's going to draw 6 degrees later, then it's going to draw 6 degrees later, 6 degrees later, so forth. Each second is going to be 6 degrees beyond what the last one was. Well, it turns out the minute hand has the same deal. If you look at the minute hand here, I said degrees in. It's JJ minute times 6, the same reasoning. The minute hand does the same thing. The minute hand also has to travel between here and here, between here and here, and so forth. So the minute hand is just like this one. It's like degrees, degree in, I called it. It's JJ minute times 6. So therefore, I can now locate, at any given time I can locate the second hand and the minute hand. The hour hand is the freaky one. That's the weird one, okay? Now, the hourly hand, what does it do? In a whole hour, in 60 minutes, it only goes 30 degrees in 60 minutes. And it goes 30 more in the next 60 minutes. 30, so in other words, what it does, it goes 30 degrees per hour. So what I did is I took the hours and multiplied it by 30, because that's how many degrees it goes per hour, whatever time it is. At 1 o'clock, it has gone 30 degrees. At 2 o'clock, it's 2 times 30, it's gone 60 degrees. At 3 o'clock, it's gone 3 times 30, it's 90 degrees. So in other words, that's where the hour hand is. However, the hour hand does move between these two also. So what I did is I said, okay, it's 30 degrees at 1 o'clock, but supposing the second hand is down here. So the minute hand is down here. So it's like 130, okay? Well, what happens is if you divide that 30 by 2, it's halfway between 30 degrees, and therefore the hour hand is halfway between this point and this point. In other words, you add the number of hours times 30, which gives you how many degrees it is when it's locked onto its actual hour. And then when you take the minute hand, you divide that by 2, and turn that into degrees, you move the hour hand properly, because it's 30 degrees here, between here and here. Because the 60 degrees, 360 degrees, or 60 movements of the minute hand. Okay, it's got 60 minutes, so therefore I say if 60 divided by 3 means it's halfway between here and here, at half past. It's 3/4 of the way when you get 145, and so forth. So in other words, if you look at the formula, you'll see it actually explains why the hour and the minute and the second hand are in the positions they're in. Just an arithmetic problem. And it's not higher math or anything, it's just arithmetically you have to adjust everything. And so these three things, what they do, they tell me how many degrees should the second hand, how many degrees should the minute hand, how many degrees should the hour hand have. And then what I simply did is, I did a drawing in paint, and I took these drawings, and I told them what angle to be at as they're in paint, pointing at different things. Now, one thing I should say, this is just a rotation. These are just 3 rotations, and nothing else going on here. And you've already written one homework with rotations, so you know how they work. I also have this thing looping, because the clock is always running. It's always looping. Now, I want to talk about something about looping with these set time. The set timeout thing that we've been using here. When you say set timeout, blah, 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 whatever it is, okay, what happens is it says, go to this function right here, go to this function, in this amount of time, whatever amount of time it is. But here's what happens. As it comes down and it hits that thing, it sets this clock in another thread, but it doesn't do anything. It's out there sitting out there, and then you hit the end of the routine, and now the rest of your program starts running. In other words, you can run these things concurrently. No matter what you do in your program, this will not interfere with it. It can be doing this on its own while your program is doing something entirely different. Because it always hits the end of this thing, and then for 30 milliseconds, it's got all the time you need to do whatever you want to do, and then it comes back and it takes an infinitely small amount of time, and it comes back for another 30 milliseconds. So basically, you never have to worry about your computer being hung up in that loop. That loop is not going to hurt anything.